So members, let us see how we can apply the anti-normalization of getting the value of the z given the probability. So let us see this example. Given that x follows a normal distribution, this one is what it means. Find this. Now they are giving us this. Now, if it follows a normal distribution, what's here is always the mean, and what's here is called the variance. So if we compare these two, if I compare this with n 60,25, you consider it that from there, my mean is going to be 60, then my sigma squared is going to be 25. But to get something standardly normal, we always need sigma, which will be 5. So from there, now I have my part A. So I want to get this value of x, find x in here. So now my probability of x less x is equal to 0.9772. Now this one is not yet in z, these are values of z. So if I convert also this to z, so this will be now the probability of now z less this x minus the mean, which is 60, divided by 5, equal to 0.9772. As you've seen from the last lesson, that we always do some sketching for this to know the value. So if I get you this, diagram here, so it's that what I'm looking for is this value less than this. Now this is our ZP. So if you start this is greater than 0.5, so meaning it's going to be this side ZP. This will be our 0. So we are looking for this value here. But remember, the whole of this will be 0.5 plus b. And now here they are giving us this is the value of b, which is 0.9772. So if you have that, now we're looking for p. So our p will be equal to, and take this side, 0.4772. Now we get the value of z corresponding to this. When we go into our tables, now I look for this value 49772. When I come to do my table, I think you can see that value. We are going for 4772. So we come this side and look for 4772. Around it's that it's close to this. So it's going to be 7772. 7772. I think it's the values there. 0.4772. Its z is 2 and 0. So this one is giving us 2.0. Now means that the whole of this, now our x minus 60, the whole over 5 is equal to our zp, which is equal to 2. When we cross multiply there, we get x minus 60 equal to 10, and so our x will be 70. So that's how we use the anti-normalization. Now when we come to part B, we want us to estimate the interquartile range. Remember, the interquartile range is given by Q3 minus Q1. So you need to get now that. So meaning you get Q3 first and also you get Q1. So now you get probability of x less Q3, but you say that the third quartile, this is the third quartile, this is the first quartile. The third quartile is always equal to 0.75. Now we normalize it. So z less, now this is our x minus our mean, which is 60, the whole over 5 equal to 0.75. So it's that this value is less. So now we come and you do these sketchings so that you can easily see what you are dealing with. You see this one is less and this one is 0.75, so it's going to be this side because it's above 0.5. 5. So this is the value we are looking for. So they are giving us this probability. But under the whole of this probability is equal to 0.5. We add this. Then we say that this is our P. So plus P. But they are giving that the whole of that is 0.75. So that's our P. Here it's going to be 0.25. Now if this is our P, we come and look for our ZP. So using the table, I think you can see that now that one is a good, it's perfect. So you go to critical. Critical, we have these ones of 0 and 5. I think you see it's very there. 0.2, 0.2 is here. I think you can see 0.25. And the value of Z is 0.674. That's the value of Z, which is corresponding to 0.2 P, which is 0.25. So meaning that now our Q3, now this is our ZP we are looking for. Over 5 is equal to ZP, now equal to 0.674. If you cross multiply there, our Z3 will be, and take this 60, then plus 5 times 0.674. And so our Q3 will be, get your calculator, then you press that. So mine here is going to be 0.5 times, then plus 60. So here I'm getting 60.337. So that's my Q3. Now I also come and I get my Q1, the first quartile. But our first quartile, we know that Px should be less than Q1. But the first quartile is always equal to 0.25. So now we standardize it. This will be Z less Q1, then minus 60 over 5 equaling to 0.25. Now to sketch that, you see it's less than 0.25. Now if we sketch it, it's going to be something similar to this. This is our 0. Now it's a standard normal because of this process. Now you see, it can't be this side. Why? Because to be this side, if it's less, to be this side, you should exceed 0.5. So if you're not exceeding 0.5, then you are this side. So this one is now, it's going to be now negative ZP. So this probability they are giving us, but we say this probability is always 0.5 minus P. So now they are giving us that. So meaning, 0.5 minus P is equal to now this value 0.25. Take it this side, our P, and take this side, be 0.25. Now if we have that as our P, then we come and get our ZP, which is going to be 0.674. So our ZP now is going to be negative 0.674. So now meaning that the whole of this is equaling to that, implying that now our Q1 is equal to ZP. This is negative 0.674. So from there, our now Q1 will be 60 when we take this side, then plus 5 times negative 0.674. And so our Q1 here is going to be 56.63. After getting that, now I come for my interquartile range. Interquartile range for that is going to be, say, Q3 minus Q1, which will be, our Q3 is here, 60.337, then minus Q1, 56.63. So our value there we get is So that's it, members. Get more examples. We are going to see more examples about the anti-memorization in the next lesson.